Klondike Goldfields, Yukon Territory. Summer of 2014, Parker Schnabel's operation is running at full capacity. 8 excavators, 12 haul trucks. A wash plant the size of a small house. The diesel engines roar 20 hours a day. The fuel trucks arrive every 72 hours. The paychecks go out every Friday. The gold is coming out of the ground at a record pace, and Parker Schnabel is slowly going broke. Not because he's a bad miner. He's one of the best. Not because the gold isn't there. It is. He's going broke because of a mathematical reality that has plagued every modern placer. Operations since the 1980s, operational costs are devouring the profits faster than the gold can replace them. Here are the numbers. A modern Klondike operation excavator's hauled trucks. Wash plants burns through roughly 60% of its total revenue just to stay operational. Fuel costs alone can run $40,000 per week. Labor-skilled equipment operators, mechanics, support crads another 30 to 40%. You're mining 120 ounces of gold per week at $1,800 an ounce. That's $216,000 in revenue. Your costs? $130,000. Your margin? $86,000. Before taxes. Before repairs? Before the inevitable breakdown that costs you 3 days of production. This is the trap. The faster you want to move dirt, the more equipment you need. The more equipment you need, the more fuel you burn. The more fuel you burn, the more crew you need to maintain it. The tighter your margins become. Eventually, you're running just to stay in place. By 2014, the economics of modern placer mining had created a paradox. The only way to make money was to mine faster. But mining faster was making it harder to make money. And Tony, Beets, the 63-year-old Dutch immigrant, who had been mining the Klondike for 35 years, understood this better than anyone. He'd built his empire on a simple principle: move more dirt for less money than anyone else. But even Tony was feeling the squeeze. His operation was running 10 excavators, 15 trucks, 3 wash plants. His fuel bill was astronomical. His payroll was crushing. To remain the king of the Klondike, Tony needed to break the equation. He needed a way to process 10,000 cubic yards of pay dirt per day without the fuel costs, without the massive labor overhead, without the endless mechanical failures that plague modern equipment. The conventional wisdom said the answer was newer, faster machines. Invest in the latest Caterpillar excavators. Buy more efficient haul trucks. Upgrade your wash plant. Spend $3 million to save 15% on fuel. Tony Beets looked at that conventional wisdom and saw exactly what it was: a treadmill. You spend more to make more, but your margins never improve. You're still trapped in the 60% cost structure, so Tony did what most people would consider insane. He bought a machine that was built in 1938. Tony Beets is not an engineer. He has no degree in mechanical systems or industrial efficiency. He's a farmer's son from the Netherlands who came to Canada in 1984 with $800 and a work ethic that most people would consider pathological. His education in mining came from 3 decades of moving dirt in the Yukon. He learned by doing, by failing, by watching what worked and what didn't, by understanding that in placer mining, the only number that matters is cost per cubic yard processed. Everything else is vanity. By the early 2010s, Tony controlled more than 17,000 acres of mining claims in the Klondike, more than any other individual miner in the district. His operation was the largest family-run placer mine in North America. His children, Kevin, Mike, and Monica, worked alongside him, running excavators, managing wash plants, driving haul trucks in conditions that would break most people. But Tony had a problem. His empire was built on volume. He needed to move massive amounts of overburden and pay dirt to hit his targets. And every year the cost of doing that was climbing. Fuel prices were rising. Equipment costs were rising. Labor costs were rising. His margin, that precious gap between revenue and cost, was shrinking. He'd seen this movie before. In the 1980s and 1990s, dozens of mining operations had gone under because they couldn't control their costs. They had good ground. They had good equipment. But the economics killed them. Tony refused to let that happen. The inciting incident came during a conversation with an old-timer at a mining equipment auction in Dawson City. The old man told Tony about the dredges, massive bucket line machines that had dominated Klondike mining from the 1900s through the 1960s. These weren't the small suction dredges. You see, on reality TV, these were industrial leviathans. 350 tons of steel and timber. Some of them were over 200 feet long. They could process 5,000 cubic yards of gravel per day, and they ran on electricity. The old-timer mentioned that one of these dredges, dredge number 1, was still sitting in Eureka Creek. Where it had been abandoned in 1959, it had been underwater for decades, rusting, forgotten. Everyone assumed it was beyond salvage. Tony asked a simple question. What did it cost to run? The old-timer laughed. Pennies. Maybe 10 or 12% of revenue. The things were powered by on-site generators. No fuel trucks. Minimal crew. You could run the whole operation with 8 people. Tony did the math in his head. 12% versus 60%. If he could get one of those dredges operational, he could cut his cost structure by 80%. He could process the same volume of dirt for a fraction of the cost. He could mine ground that was marginally profitable and turn it into a gold mine literally. But there was a catch. Multiple catches. First, the dredge was underwater. It had been sitting in Eureka Creek for 55 years. Decades of ice, water, and neglect had taken their toll. No one knew if the hull was even intact. Second, even if it could be salvaged, it would need to be disassembled, moved, and reassembled. The dredge weighed 350 tons. It was held together with thousands of rivets, bolts, and welds. Moving it would require dismantling it piece by piece and transporting those pieces, some weighing over 10 tons across, rugged terrain on dirt roads. Third, once moved, it would need to be completely rebuilt. Every motor, every bearing, every gear, every bucket on the bucket line. Components that hadn't been manufactured since the 1950s would need to be fabricated from scratch. Fourth, the entire project would take years. Years during which Tony would be pouring money into a machine that wasn't producing a single ounce of gold. His competitors would be mining. He'd be rebuilding. And fifth, the biggest catch of all, everyone thought he was crazy. His own crew was skeptical. His family had doubts. Industry experts openly mocked the idea. Why would you spend $1 million on a 75-year-old machine when you could buy a brand new excavator for half that price? Tony's answer was simple. Because the excavator burns diesel. The dredge doesn't. If you, like us, believe that human ingenuity and ruthless economic calculation can solve any problem, click the subscribe button below and tell us in the comments what part of the world you're watching from. The engineering genius of bucket line. Dredges isn't immediately obvious. To most people, they look like floating monstrosities, Frankenstein machines from a bygone era. But to anyone who understands industrial efficiency, they're masterpieces. Here's how they work. A bucket line dredge is essentially a self-contained floating factory. The hull of a massive steel barge sits in a pond of its own creation. As the dredge processes gravel, it digs itself forward and deeper, creating the water it floats on. The business end is the digging. Ladder a steel framework that extends from the bow of the dredge at a 45-degree angle into the gravel bed. Attached to this ladder is a continuous loop of buckets, 72 buckets on dredge number 1, each capable of holding 4 cubic feet of gravel. The bucket line is driven by an electric motor. As the motor turns, the buckets dig into the permafrost and gravel, scoop up material, carry it up the ladder to the top of the dredge. At the top, each bucket tips over, dumping its load into a hopper. From the hopper, the material flows into a rotating cylindrical screen, the trommel. The trommel is 6 feet in diameter and 20 feet long, perforated with holes. As it rotates, water is sprayed onto the gravel. The smaller material, the gold-bearing pay dirt, falls through the holes and onto a series of sluice boxes lined with riffles and miners' moss to catch the gold. The larger rocks and Boulders continue through the trommel and are discharged out the back of the dredge via a conveyor belt called the stacker. The stacker creates the tailings piles, those distinctive rows of gravel that mark the path of every dredge operation. The entire system is hydraulic and mechanical. No internal combustion engines. No diesel fuel. The dredge generates its own electricity using onboard generators, or in later models, by connecting to a power line. The operational crew? 8 people. 1 operator controls the digging ladder. 1 operates the winches that move the dredge forward. 2 workers manage the sluice boxes and clean up the gold concentrate. 3 mechanics handle maintenance. 1 supervisor oversees the operation. Compare that to a modern excavator operation. Parker Schnabel's crew runs upwards of 25 people. 5 excavator operators. 8 truck drivers. 3 plant operators. For mechanics. The rest are support fuel handlers, laborers, cooks. The fuel consumption difference is even more staggering. A Cat 390F excavator, workhorse of modern Klondike mining, burns approximately 18 gallons of diesel per hour. Running 20 hours a day, that's 360 gallons per day. At $4 per gallon in the Yukon, fuel is expensive up there. That's $1,440 per day, per excavator. Parker runs 8 excavators. That's $11,520 per day in fuel costs alone. Over a 100-day season, $1.15 million. Just for excavators. Add in the haul trucks, and you're pushing $2 million in fuel costs. The dredge, once operational, its primary power source is electricity. Dredge number 1 was designed to run on a 440-volt system powered by onboard generators. Those generators burn diesel, yes, but far less. Approximately 70 gallons per day for the entire operation. That's $280 per day. Over a 100-day season, $28,000. The math is undeniable. But the execution, that's where Tony's crazy idea became a legendary engineering challenge. Salvaging the dredge began in 2013. Tony and his sons traveled to Urica Creek and surveyed the wreck. The dredge was partially submerged, its hull breached in several places. Ice had pushed the structure sideways. 55 years of freeze-thaw cycles had warped the steel. The wooden components, the sluice boxes, the catwalk decking were rotted through, but the bones were good. The main hull structure was intact. The digging ladder, though rusted, was still straight. The bucket line was there, frozen in place, like an industrial sculpture. Tony made the decision. They would salvage it. Every piece the disassembly took 2 years. Using torches, grinders, and hydraulic jacks, the crew cut the dredge apart, section by section. The digging ladder was removed, first a 20-ton assembly that required a crane and a flatbed trailer to transport. Then the trommel. Then the sluice frames. Then the hull itself, cut into manageable sections. Each piece was cataloged, numbered, and transported 60 kilometers to Tony's primary mining site at Paradise Hill. The roads were dirt logging roads, barely wide enough for the oversized loads. Every trip was a gamble. A broken axle, a collapsed bridge, a rainstorm that turned the road into a mudslide. It took 47 truckloads to move the entire dredge. Reassembly began in 2015. Tony hired welders, millwrights, and fabricators, men who understood old steel and riveted construction. They built a dry dock and began reconstructing the hull. Every seam had to be rewelded. Every rivet hole had to be redrilled. The wooden decking was replaced with new timber. The trommel was sandblasted, patched, and remounted. The bucket line presented the biggest challenge. Each of the 72 buckets had to be individually rebuilt or replaced. The steel had thinned from decades of abrasion. Tony's crew fabricated new buckets using 1/4-inch steel plate, bending and welding each one by hand. The chain links that connected the buckets, each link weighing 30 pounds, to be inspected and replaced where necessary. Then came the motors. The original electric motors were seized beyond repair. Tony sourced replacements from industrial salvage yards across North America, 3-phase, overpowerful enough to drive the bucket line in the trommel. The winch motors, which moved the dredge forward by pulling on cables anchored to the pond bed, were completely rebuilt. The sluice boxers, the heart of any gold recovery system, were redesigned. Tony consulted with old-timers who had worked on dredges in the 1950s and incorporated modern improvements. Expanded metal riffles, high-grade miner's moss, adjustable slope angles to optimize gold capture. By 2016, the dredge was 70% complete. By 2017, it was floating in its own pond at Paradise Hill. Tony fired up the generators. The motors hummed. The bucket line began to turn. For the first time in 58 years, dredge number 1 was alive. But Tony's problems were just beginning. The mining community didn't know what to make of the dredge. To many, it was a curiosity, a museum piece that Tony was wasting time and money on. While Tony was rebuilding a 75-year-old machine, his competitors were mining gold. Parker Schnabel was pulling in record seasons. Other operations were expanding. Tony's own crew was frustrated. His children, Kevin, Mike, and Monica, had invested years of their lives into the dredge project. Years during which they could have been running excavators and moving dirt. The skepticism was constant. Why are we doing this? When is this thing actually going to make money? Dad, this is insane. Even the camera crews from Gold Rush began to lose interest. The dredge rebuild was slow, methodical. There were no dramatic explosions or catastrophic failures, just welding, fabrication, and incremental progress. It was boring television. Some fans openly complained that the dredge storyline was dragging down the show. But the real conflict wasn't with the crew or the cameras. It was with the machine itself. Getting the dredge operational was one thing. Getting it to run efficiently was another. The first test runs were disasters. The bucket line kept jamming. The buckets would dig into the gravel, but instead of scooping material cleanly, they'd hit frozen permafrost and stop dead. The motors would strain, overheat, and trip the breakers. Tony's crew would spend hours chipping away the ice by hand before they could restart. The trommel screen kept clogging. The perforations were too small for Yukon gravel, which contains more clay than the California gold fields the dredge had originally been designed for. The clay would pack into the screen holes, choking the flow. Tony had to retrofit the trommel with larger perforations and add a spray bar system with higher water pressure. The sluice boxes weren't catching gold efficiently. The flow rate was wrong. The slope was wrong. Gold was washing over the riffles instead of settling behind them. Tony's crew ran test after test, adjusting the angle, adding more riffles, experimenting with different types of miner's moss. Each failure cost time. Each adjustment required shutting down the dredge, making modifications, and testing again. All while the clock was ticking on the short Yukon mining season, barely for months.
8.
Between ice-out and freeze dash up. And then came the real crisis. In the summer of 2017, during a full production run, the main winch cable snapped. The winch system is how the dredge moves forward. Steel cables each, 1 over an inch thick car, anchored to Deadman large anchors buried in the pond bed ahead of the dredge. The winch motors pull on these cables, dragging the dredge forward as it digs. When the cable snapped, it recoiled like a bullwhip. The loose end whipped across the deck, missing Tony's head by inches. If it had hit him, it would have killed him instantly. The crew shut down immediately. The cable had failed at a splice pointer repair that had been made during the reassembly. The splice wasn't strong enough. Tony had 2 options. Order a new cable, which would take weeks to arrive and cost $20,000, or resplice the cable himself and hope it held. Tony chose the latter. He and his crew spent 3 days splicing the cable, using a technique called a Liverpool splice, a method of interweaving the cable strands to create a connection stronger than the cable itself. It's a lost art taught by old riggers and rarely used in modern industry. The splice held. By late 2017. The dredge was running consistently. The bucket line was digging cleanly. The trommel was processing gravel without clogging. The sluice boxers were catching gold. But Tony still hadn't proven the economic case. The dredge needed to process enough volume at a low enough cost to justify the millions he'd invested. The test came in the summer of 2018. Tony ran the dredge continuously for 6 weeks. The crew tracked every metric: cubic yards processed per day, gold recovered per cubic yard, fuel consumed, labor hours, maintenance costs. The numbers came back.
The dredge was processing an average of 4,500 cubic yards per day, comparable to a 2-excavator operation. But here's the kicker. The operational cost was $18,000 per week. A 2-excavator operation running the same volume? $65,000 per week. The cost per cubic yard? $4 for the dredge. $14 for excavators. Tony had done it. He'd broken the equation. The vindication came not in applause or recognition, but in the cold, hard reality of the numbers. And the 2019 mining season, dredge number 1 ran at full capacity for 94 days. It processed 423,000 cubic yards of pay dirt. The gold recovery averaged 0.035 ounces per cubic yard, not spectacular ground, but decent. Total gold recovered, 14,805 ounces, $1,800 per ounce. That's $26.6 million in gross revenue. The operational costs, fuel for the generators, labor for the crew, maintenance and parts, totaled $3.2 million. Approximately 12% of revenue. Net profit, $23.4 million. From a single machine. With an 8-person crew. Compare that to Parker Schnabel's operation in the same season. Parker moved over 4 million cubic yards, 10 times more than Tony's dredge. His gross revenue was higher, but his operational costs consumed 62% of that revenue. His net margin, while impressive, was proportionally much smaller. Tony's Obsolete machine had become the most profitable single asset in the Klondike goldfields. The impact went beyond just one season. The dredge gave Tony a strategic advantage that none of his competitors could match. He could mine ground that was economically marginal for excavator operations, ground with lower gold concentrations that wouldn't justify the high operational costs of modern equipment. But with the dredge's 12% cost structure, even marginal ground was profitable. Tony began targeting his deep, low-grade claims, thousands of acres that he'd been sitting on because they weren't rich enough to mine with excavators. With the dredge, they became gold mines. By 2021, Tony had acquired and begun restoring a second dredge, dredge number 2, an even larger machine from the 1940s. His long-term vision, a fleet of 3 operational dredges, each one processing 4,000 to 5,000 cubic yards per day at minimal cost. Together, they would make Tony Beets the undisputed king of the Klondike, not because he mined the most dirt, but because he mined dirt more efficiently than anyone else. The reaction from the industry was mixed. Some old-timers applauded Tony's vision. They'd worked on dredges in the 1950s and knew how efficient they could be. They saw Tony's project as a validation of old-school engineering over modern brute force. Others dismissed it as a novelty. Sure, Tony made it work, they'd say. But he's Tony Beets. He's got the resources, the claims, the crew. It's not practical for most miners. They were right, of course. The barrier to entry is enormous. You need the capital to buy a dredge, the expertise to rebuild it, the patience to see the project through years of setbacks, and the mining claims large enough to justify the investment. But that misses the point. Tony Beets didn't restore dredge number 1 because it was practical for everyone. He did it because it was practical for him. He saw a problem, the unsustainable cost structure of modern placer mining, and he solved it by looking backward instead of forward. He ignored the conventional wisdom that newer is always better and instead asked a simple question: what's the cheapest way to move dirt? The answer was a 75-year-old machine that everyone else had written off as junk. That's the legacy. Not the gold. Not the revenue. The lesson in an industry obsessed with speed and scale, Tony Beets proved that efficiency matters more. In a world that glorifies innovation and disruption, he proved that sometimes the best solution is the one your grandfather used. The dredge isn't just a machine. It's a testament to the idea that the old ways aren't always obsolete, sometimes they're just forgotten. And when a 63-year-old Dutch immigrant with no engineering degree can take a rusted piece of industrial history and turn it into a $16 million per season profit engine, It's a reminder that ingenuity isn't about having the latest technology, it's about understanding the problem better than anyone else. Stories of practical genius like this are everywhere, hidden in the footnotes of industrial history, buried in the archives of forgotten trades, waiting for someone stubborn enough to dig them up. If you enjoyed this deep dive into Tony Beets' Dredge Masterclass, subscribe for more and don't forget to leave a comment below telling us where you're watching from. Until next time.